I start the keynote about LCA and reality, which is a bit deep topic, of course, but it's hopefully interesting, and I maybe have some points, but you can decide. This is on the right, a very nice picture of, can I get the mouse away? No. It's okay. A very nice picture of reality. Reality can, of course, also be nasty and not so nice, but LCA is more a bit like this. So as you see on the left, a very clean box, and that's not really linked to reality. And so I think that's a bit a disconnect, and I think that's contradicting to maybe the original idea of life cycle assessment. Because I think it was always the idea that LCA represents the real world in a holistic, as objective as possible manner, avoiding shifting, and which is also linked to this understanding that some say that life cycle assessment is science-based or so that really it's a concept of empirical science that makes a lot of sense. Yeah? So therefore, let's maybe explore this a bit. And the science term for LCA came about quite a bit. Already in 2005, UNEP said we need a method, an approach that is science-based. Yeah? So that's not such as life cycle analysis, they call it. It's not saying it is science. Oh, okay, perfect. It is science-based. And that became more serious with the ICD handbook from the European Commission, who said that.
Ich wollte nur das Mikro ein bisschen hören.
Oh, sorry. Who's I need to see the slides also. who then put it a bit level more serious, that they said LCA is the science-based approach. Yeah, so that is really a statement. And if you look what this means, key characteristic of science, empirical and evidence-based, logical reasoning, testifiability, falsifiability. So that is quite reproducibility. That's quite, if you really claim this, it's quite a lot. And I think it was a bit that this was happily adopted, that people said, yes, this is of course science-based, but then it was not really taken so seriously that you, when you do it, you really apply science, so to say. And I had already quite early in 2006 written an editorial for the Life Cycle Assessment Journal. I said it's basically quite difficult to validate really LCA results, because it's very different from, I had then the picture building a ship. If you build a ship, then you can also follow rules and do this correct as possible and have this build reviewed. But if you then push the ship to water and the ship the ship sinks, then you failed. And in LCA, you can calculate the carbon footprint of a product over the life cycle and say it's 750 kilos, and no one can say, but it's incorrect. Yeah, so you cannot put this life cycle assessment result to a test, really, and that's the difference. And then, of course, when this a bit iconic picture, we also contributed how you really make a unit process data set. Seriously, many details of a unit process in reality are not known, even for several reasons, because some maybe emissions that you need for the process are not measured on site, so no one knows that really, and you don't have access to the site. Then you need to typically allocate maybe the total energy demand for the building to one machine that is producing one unit of product, and how this is really happening, that's a bit more your setup and not really testable, and so on. And then, of course, we all know, everybody who is in LCA, that it's not easy to get details from a company that is involved in a highly sensitive production environment. And then, that was inventory. Then impact assessment also, of course, you cannot really say here in my backyard, this emission has exactly this impact. So that was recognized a long time ago, and therefore you know that LCA says this is potential impacts, not the real impacts. Yes. And I think this distance was recognized early in the development of LCA, and is also somehow accepted today, but then you still have this claim And also I think it was a bit that LCA's method is now a bit old already, you can say, with these early developments in the 1990s. And it's a bit that this status has been accepted and it has not been challenged. And I think we've now much better technical possibilities and also much more data. And LCA as a method has become much more important so that we can make more effort to really link LCA better with reality than was done before. And this is, I think, an opportunity, but then it brings also responsibility. And I think we see now quite many developments where LCA results are started to get taken seriously. If you just think of CBAM or in procurement or so, where really it matters if your product has this or this LCA result. And so therefore it makes it even more pressing that you just don't provide a made-up number, but one that's really reflecting what the product really is. And that is quite difficult to link LCA with reality, but maybe also LCA hasn't cared so much about it and has developed a bit in the world of its own. And I have some few examples, there are many more, but just to discuss. That is, first example is real case from a project from where I was involved recently. That is, in environmental product declarations, you typically often only assess bill of materials and not the real product. Yeah, so the emissions of the process itself, but you just account for the impacts or the inputs of this process. And that is a real case, complex machinery making process. And oh no, so I destroyed this, I don't have a pointer, right? But you see, so red is so blue is the EPD result as it was in a draft. And then I said, okay, but let's now, it's a bit clearly you're forgetting some impacts, so let's add just as an increment general machinery management or so effort, this with the mass that you have, and that really doubled the impacts roughly, in all the categories, mostly. So that's quite a difference. And that just because of convention, you really forget quite a lot of the impacts. And then this is an old case, and it's a bit maybe now not so important anymore, but we all know that economic has these uncertainty factors, and sometimes ago it was very popular to make Monte Carlo simulations with these uncertainties, and they're basically, which you also see in openLCA, and basically these are determined that you have data quality scores, 1, 2, 3, 4, 5. It's, for example, time, how old is your data set? And that then economics says this makes this uncertainty. It's an exponent, so it's a geometric standard deviation, so it's an exponent that you see here. 1 is basically 0 uncertainty, and then 2 is quite a lot of uncertainty. And that is not documented how Ecoment came up with these numbers, and we had some time ago a project to investigate this on available data back then. So it was finished in 2010, I think, or 12, so quite some time ago. And then we found that for some cases, the real factors are this, and not available is that we decided, okay, when we have a factor of 5 or higher, then we shouldn't publish because this is really e to the exponent of 5, so it's really a lot, and meaning it's totally uncertain. And it's quite a contradiction, as you see, to the broadly used equivalent factors. So, for example, geographical correlation 5 is 1.1 or 5 is exponent, and that's just really a difference. Next example is transport. It's of course quite an important topic for many LCA studies, and it's if you have a truck, then the emissions of this truck depend of course a lot on the payload of the truck. So if the truck is almost empty, then it has per ton kilometer a lot of impacts, and if it's very full, it has per ton kilometer much lower impact. So you see the blue line is the whole vehicle that of course has higher fuel demand if it's more heavy and transporting more, but it's an offset. And then the per ton kilometer, you have this red line, and that is becoming much more efficient if the truck is full. And in average, it's depending a lot, and I didn't investigate too much, but in average you have 69% maybe of payload for heavy trucks. And equipment since beginning, I think, calculates just with all half full trucks all the time. Yeah, so it's not really, and also it doesn't give you as modeler a chance to modify this, which is of course also a limitation. Then, and it's my second last example, sorry, I don't want to show that everything's not good, but it's just maybe really a time maybe to change things and maybe also to modify things. Omission of infrastructure, which is also very common, for example, in all the Gavi databases, I think. And that is, of course, also a simplification. If you just check from Eurostat, this is the average investment rates of average corporations, so companies in infrastructure, and you see that 25% of the expenses are linked to infrastructure. And that means you should also see maybe some impacts in the LCA and not say this is not relevant, yeah? But it's not done typically. And then the final, that is from last conference, final thing that we also, it's a bit linked, that we in LCA maybe continue too much on using old technology, but just because we think this is how you do it and are not so open for innovations. And that is just an example where I tested last year how to read and write the IGBLIS database in ICD format and in JSON format from openLCA, and you see that it's, I think in seconds, sorry, and you see that reading the entire database takes maybe 5 times more time than in JSON. Yeah, so and that's also one point where we could maybe improve in LCA. So my point is not that to show that LCA is not perfect, because no method is perfect. My point is that these existing disconnects to reality are not really challenged. And we just say this is because the standard says it, it's because this other study does it, and so we should innovate also here. And we should avoid that we are in a self-referential, disconnected world. So not that we say, okay, there's a thick line between reality and LCA is linked to standards, to conventions, and to we have done this before, and so therefore we do it again. So how can we do this? Maybe, and I don't have a complete solution, of course. First, why is this better? Yeah, and I think for 2 reasons. One, a good representation of the real world is implicitly already claimed now. So when you really say in CBAM, for example, we charge customs fees for Chinese products or so that enter the European markets, and they are depending on the LCA result, then of course we claim somehow that this is not a made-up number, but that this is somehow representing the real product. And I think also decisions are better, more fair, more objective, if they are better based on reality. Then I think it's in this world where LCA results are becoming more considered more seriously, so to say, there's also, it's a bit like competitive angle, and there's maybe you could say race to the bottom that everybody's trying to get a lower carbon footprint, for example, result. If you do this only because you make infrastructure and only look at the inputs into your process and not at the emissions of your process, then it's not really helping the world, and that is really not a good development. And final point, we now see a lot of, and we also are involved in this developments to use artificial intelligence for LCA, and there you should also not train your model so that it represents exactly equivalent 3.2 or 3.10 or so, but real emissions, I think. Yeah? And therefore this is also interesting to think how LCA can be linked to reality. So how can this be done? First, maybe you have seen something like this before. So, and it's not everywhere, of course, reality should be involved, but here. Yeah? Inventory analysis and impact assessment. And then if you take, that's maybe also familiar also from the ISO standard, this product system, there are many different, and it would be a lecture on its own, maybe which part that's possible. but you can imagine that there are different elements and aspects that could be linked to reality, but I have some examples. First, impact assessment, that is maybe in a way easier if you do this on a lab scale or so, on a smaller scale at least. There's several good examples. Climate change has received a lot of attention, and there are really good examples, but also for other impact assessment methods, categories, there are examples growing, and I think this is good. And then for inventory, it's much less. And this is a study that I did with Michael some 10 plus years ago or so, where we, based on a study where we investigated yogurt cups, or at least plastic packaging, and it was not clear how heavy the packaging is. And then this, of course, determines directly the impact of the study. So if the yogurt cup weighs 2 grams or 4 grams, then you basically have twice the impact overall, roughly. Yeah? So therefore, it's quite important to understand this. And the producer couldn't really tell this, or didn't, at least. And so we said, okay, let's make a study. And we really just investigated different, also we had a map of all the supermarkets in Berlin, drew then a sample from which supermarkets we need to visit, and then at the supermarket bought yogurts, and we ate them, and weighed the cups. Yeah? And that is the result, so that we say this is overall the weights of the cup. It was one size, so that it's a bit comparable, 150 gram, but it was different brands and so, of course. Yeah, and then we clustered and so on. It was really possible, because this is information basically that's available without talking to the producer. We could really say, okay, the yogurt cup basically has this range. Yeah, and that's something that's not really done otherwise often, I think. Then we have many new data sources that can also, of course, be used as an input for LCA. Of course, there's like climate trace, for example, which is quite nice, and you can drill down and say, okay, here this, whatever, Hennigshofer electric steelworks have these emissions. Of course, sometimes you need to check if they are, again, using just LCA data or how this was obtained, but this is at least a chance. And also, SDR, for example, is a very nice source for agricultural data, where really they collect on farm. And we had yesterday some people from Blog, for example, were in our office, and they explained they've done something similar for the Netherlands also. So there's quite some developments, I think. Yeah, and then I think it's also good that we build a different database for LCA that I've talked about already maybe 2 times at the conference, and I will talk about this and show this tomorrow also. But then also, I think in LCA, we are a bit approaching the world a bit in a too not very intelligent way, so to say, because we more go in a footpath approach and just say, okay, we are now here and so, and that really avoids us to see patterns easily. And there are patterns in real world, and that is good to recognize them and to use them for modeling. And therefore, we since sometimes use a lot of system dynamics, and there will be some examples in the system dynamics session. Yes, and final point here, it's also good if we keep LCA elements verifiable. So that is one of these scientific criteria, or criteria for science. And how can this be done? Yeah, it's of course, when you see a system process, you can really barely verify this, because you can maybe say, okay, the overall amount is quite a lot and different from others, but you don't really see insights into the process, and therefore there's you need to believe this basically, and this is a disadvantage. LCA results are even less verifiable in that sense. EPDs, so environmental product declarations that use a lot LCA results and other aggregate indicators are then less verifiable, but I think you know that EPDs have a very elaborate review system in place that somewhat tries to take care of this, and I think it works also to quite some extent, but still there's also room for improvement, and unit processes are really easier and therefore better, but a really external review is not really often done in my view. So conclusions, I'm not sure how I'm doing with time, but Yeah, okay. I think with increased possibilities, increased importance of LCA results, it is time to challenge and LCA and also ourselves as LCA community so that we are more awake and prepared to question established things in LCA, which means methods and also technologies that we use. It is time, I think, to become creative again, and to think again, to exchange and to discuss. And of course, we need to be constructive, so not say this is all rubbish or so, but I'm not sure how to translate konstruktives Misstrauensvotum, but this is in German policy, if the chancellor in the parliament doesn't get support from the parties, then you can't just say the chancellor is out of power, but you need to have a majority for voting the next chancellor. Yeah, so that somehow this is this. And I think that makes sense, so that we don't say this is all nonsense, but that we say, yes, and we have a better solution, ideally. And that fits, I think, very nicely, maybe as starting speech for the conference, because here we are really here to exchange ideas, to challenge also presentations, I think, to discuss and to learn something and maybe to get new ideas. So with that, welcome to the third conference we have.
Thank you, Andreas, for the nice introduction. I wanted to keep on the topic on the evolution of LCA. I think it's even older than 30 years. I claim that it's close to pension. But how do you see this evolution? Because I totally agree with you. It needs to face a new reality and way more complex systems than when was originally thought.
Yeah, I try to explain. So yeah, it's in the I think the first ISO standard was 1996 or so, and that of course there was not the first thing ever happened in the method, but that has a long run before to shape the method and so on. Then it was an ingenious, I think, move to have a standard, and that really just made a distinction to other not other environmental assessment approaches around. Of course, I don't know how this evolves, but I really see this field that, for one, LCA is really becoming to be taken seriously, and then it's in large part still done as if it was 30 years ago when I was in. I remember my first LCA conference was 1998, and that was 100 people, and then someone said, "Look, this is everybody worldwide doing LCA," and so now we are 200 or so here alone, and there are maybe 100 conferences worldwide or so. So it has really exploded, but the approach hasn't really considered this. And I think there are now quite many developments what can be improved, but I can't predict, of course. But I think it's just for us to think how things can be done a bit better, making more data available, getting more insights into data, but also having better means to challenge data and results that are presented, doing the verification and quality assurance better, the different angles, of course, and then we still have a lot of other impacts that are somehow a bit, they're really reality, but they're not so easily addressed in the common approaches, like littering, for example, or so, and that is, or plastic in the environment, so, and so there's also room there. But I think it's also good because, I mean, if I'm also working since basically 30 or so years in LCA, and if you think, okay, now it's done and it's basically boring and everything has been discussed, and then it's time to stop. But that's not the case. So we have still quite a lot of work to do, which is nice.
And a lot of things to discuss also in the conference. So thank you everyone very much. And let's move on to our next sessions. I think. Thank you a lot.